Good morning, my dear students. So we are discussing about 13th group. So in the 13th group, we have boron, aluminum, gallium, indium, and thallium. So far we discussed only about boron compounds. There is boron, borax, boric acid, and boron trifluoride, diborate. These are the 5 compounds that we studied in boron. And today we are going to take up the compounds of aluminum. So there are 2 compounds we are taking. The first compound is aluminum chloride, and the second one is ALUMs, which is a double salt. So aluminum chloride preparation is done by 3 methods. The first preparation is from aluminum metal, right? So aluminum, when heated with hydrochloric acid, it forms aluminum chloride with the liberation of hydrogen gas, right? So you got to multiply this by 3, 2 into 3, 6, you get 3H, 2 aluminum involved. Or there is one more method. Aluminum can be straight away heated with chlorine at 1000 Kelvin to get aluminum chloride. Right? So this is how it can be obtained from aluminum. The second preparation is from aluminum hydroxide. So aluminum hydroxide will have to be treated with hydrochloric acid. Then what happens? Aluminum will join with chlorine, forming aluminum chloride, and H will join with OH, forming H2. Right? So here 3 HCl and 3 water molecules are being produced. And the third preparation is by McAfee method. This is done from alumina. What is alumina? Alumina is aluminum oxide. Aluminum trioxide is made to react with coke, and then it is treated with chlorine gas. These are heated together. Then aluminum goes with chlorine, forming aluminum chloride, and carbon monoxide is being liberated. Right? So 3 carbon will have to be used. 2 aluminum chloride, you got to multiply this by 2, and chlorine is 6. 3 carbon will react with 3 oxygen, forming 3 carbon monoxide. Right? So these are the 3 methods of preparation of aluminum chloride. Aluminum chloride is a white crystalline solid. It is hygroscopic in nature. What do you mean by hygroscopic? When you say hygroscopic, it can absorb water from the atmospheric air. Right? So it's a white solid. It is hygroscopic in nature. Right? Then its chemical properties. One is with water. The aqueous solution of aluminum chloride is found to be acidic. Why? 100% kapam. 3 mark clear, 2 mark take kapam. Water la pota aluminum chloride karacha neutral solution varadu, enna solution varum? Acidic solution. What is the reason for that? Aluminum chloride, when dropped into water, will form aluminum hydroxide and hydrochloric acid. Right? Now, to balance this, multiply this by 2, it will be 6. And you got to multiply this by 3, and we'll get 12 HCl. 6 into 2, 12 hydrogen. In that we have here 6, and we'll have 6 H here. Now if you look at this mixture, this is a weak base. This is a strong acid. அப்ப இது ரெண்டும் mix ஆனா எது dominate பண்ணும்? Acid will dominate because it's strong. Strong acid character will be there. Therefore, it is found to be acidic in character, right? The second reaction is with ammonium hydroxide. So, aluminum chloride will react with ammonium hydroxide. So, when it is treated with ammonium hydroxide, ammonium will join with chlorine forming ammonium chloride, and aluminium will join with OH forming aluminum hydroxide. So you get 3 ammonium hydroxide involved, right? And the third one is with sodium hydroxide. So aluminum chloride reacts with sodium hydroxide. In this, it is forming sodium meta-aluminate. Along with that, sodium chloride and water molecule are being produced, right? So in this, 4 sodium will be used because there are 3 chlorine, we will get 3 sodium chloride. Now 3 plus 1, 4. Then 4 hydrogen and 2 water molecule will be produced. So this is how aluminum chloride is being reacting. So one reaction is there. One is with water, then with ammonium hydroxide, the third one with sodium hydroxide, right? So aluminum chloride is mainly used as a catalyst in organic chemistry, particularly in Friedel-Crafts reaction, right? It is also used to absorb water, right? These are the main uses of aluminum chloride, right? And the next compound of aluminum that we are taking up is alums. So alums are double salt, right? Alums are double salts of 2 different salt solutions, right? Mostly it is potassium, aluminum, sulfate, right? So that's particularly it is being called as potash alum. Potash alum is potassium sulfate, aluminum sulfate, aluminum valency 3, sulfate valency 2 with 24 water molecules. So this is called potash alum. Then we have sodium alum. Sodium alum will have almost same formula, right? It is Na2SO4, Al2SO4 thrice with 24H2. It's not 2, 24 H2, right? This is sodium alum. Then ammonium alum. Ammonium alum will be ammonium sulfate with aluminum sulfate and 24H2. Right. Then chrome alum. Chrome alum is potassium sulfate and chromic sulfate with 24H2. Right? So, in all these salts we have one metal and another metal here. So this is M2, M dash 2SO4, M2 dash 2SO4 thrice with 24 water molecules. This may be the common formula, that is taken here. This is mostly divalent, and this is mostly trivalent. Right? So first metal is rather monovalent. Yeah, not divalent also. Its valency is 1 only. So இது valency 1 இருக்குது, இது valency 3 இருக்குது. So அந்த மாதிரி மெட்டல் எடுத்து தான் என்ன ஃபார்ம் பண்றாங்க? The alums are made. So you should know the formula for potassium alum, sodium alum, ammonium alum, bromine alum. Right? Now, how these alums are prepared? Preparation of alums. Right? So it is prepared from alunite, a natural substance called alunite. Alunite is mainly potassium sulfate, aluminum sulfate with 4 times of aluminum hydroxide. Right? So this is the formula for alunite. This alunite is powdered well, and then first step is mixed with sulfuric acid. Then we get the sulfates of potassium and aluminum. And second step, to this some more potassium sulfate is added and crystallization is done to get the alum. So this involves 2 steps, right? So first step, this alunite, potassium sulfate with aluminum sulfate, 4 aluminum hydroxide, or heated with concentrated sulfuric acid, and it forms potassium sulfate plus aluminum sulfate and water molecule. Right? So we get how many aluminum sulfate? Here we get 2 aluminum sulfate. Right? Because there are 4 aluminum joining with 6 sulfate forming 2 aluminum sulfate. And water molecule, we'll get how many water molecules? There are 4 into 3, 12. And here we have 2. Therefore we'll get 6 water molecules. Right? 6 water molecules are being produced. So hydrogen is 6 into 2, 12. And OH, here also we have 12 hydrogen. Therefore there will be 12 water molecules which are formed. What is this? This is step 1. So in the step 2, this potassium sulfate, இது aluminum sulfate double ஆகுது, அப்போ potassium sulfate double ஆகும். You have to equalize the potassium sulfate and aluminum sulfate. Equal amount is taken and it is mixed with water molecule and it is boiled and cooled. So this mixture on boiling and cooling will form potassium. So this is how the preparation is being done. So in the step அப்புறம் இன்னும் கொஞ்சம் potassium sulfate add பண்ணுவாங்க. Add potassium sulfate and boil the solution. Because what is excess? Aluminum sulfate excess ஆகுது. எவ்வளோ excess இருக்குதோ அதுக்கு equal amount potassium sulfate add பண்ணி, after that you have to add water, boil, cool, and you will get the potassium alum. So potassium alum is a white solid, right? It is potassium sulfate and aluminum sulfate are present in it, right? So properties of alum, potassium alum. One, aqueous solution of alum is acidic because aluminum sulfate undergoes hydrolysis. On hydrolysis forms two substances. Aluminum comes out as aluminum hydroxide and SO4 comes out as sulfuric acid. So either OH zero, either H zero, water level. Now this aluminum hydroxide, this is sulfuric acid. This is weak base and this is strong acid. Right? Because acid is strong, the solution is having what character? Acidic character. This is 2 mark. Why aqueous solution of alum is acidic? It is because of the hydrolysis of aluminum sulfate. Right? Aluminum sulfate on hydrolysis gives the weak base of aluminum hydroxide and strong acid of sulfuric acid. Therefore, the mixture is acidic. Then, next is action of heat. So, potassium sulfate and aluminum sulfate with 24 water molecules, when heated to 453 Kelvin or around 500 Kelvin, it loses all the water molecules. It completely loses the 24 water molecules and it slightly becomes a swollen mass. And this is called burnt alum. Okay? Burnt alum. When this burnt alum is taken and heated to red hot condition, it gives potassium sulfate. It becomes alumina and 3 sulfur trioxide molecule will be going out. 3 SO3 will go out. So, if you have 3 SO4, SO3 3 வெளிய போய்டும். அப்ப 3 oxygen நின்னுது என்ன மாறிடுது? It changes into alumina, right? So this is how alumina is being obtained by the action of heat of potassium, right? Then the uses of this potassium. Potassium is mainly used in the purification of water. இல்லையா இப்போ நம்மளுக்கு மினரல் வாட்டர் எல்லாம் வருது உப்பு தண்ணி எடுத்து அதை குட் வாட்டராக மாற்றுறதுக்கு எதான் யூஸ் பண்ணுறாங்க பொட்டாசியம் தான் யூஸ் பண்ணுறாங்க. இட் இஸ் யூஸ்ட் இன் தி இண்டஸ்ட்ரீஸ் ஆஃப் பேப்பர் இண்டஸ்ட்ரி அண்ட் டெக்ஸ்டைல் இண்டஸ்ட்ரி. ஒயிட் கிளாத் பளிச்சுன்னு வரணுன்னாவே என்ன தான் யூஸ் பண்ணுவாங்க? பொட்டாசியம் இஸ் யூஸ்ட். திஸ் பொட்டாசியம் இஸ் ஆல்சோ யூஸ்ட் டு அரெஸ்ட் ப்ளீடிங். இல்லையா இப்போ ஷேவிங் கடையிலலாம் பார்த்தீங்கன்னா ஒரு ஒயிட்டாக ஒரு சாலிட் வச்சுருப்போம், ஷேவ் பண்ணோன்னு தேய்ச்சி விடுவோம். அப்போ எங்கே கட் ஆகிட்டு ப்ளீட் ஆகுதோ அதெல்லாம் ஸ்டாப் பண்ணி கொடுக்கும். These are the main applications of this potash alum, right? So you should know what is potash alum, what is the formula for potash alum, preparation of potash alum, action of heat of potash alum, and the aqueous solution of potassium alum is acidic. Then the uses of this potash alum, right? So with that we'll wind up today's class. Okay? So this will not be included for the test tomorrow. Tomorrow you are writing only about the boron compounds. Boron, borax, boric acid, diborane and boron trifluoride. These topics we'll take up in the next class. So after this, in the next week we are going to take up 14th group. So under the 14th group we will be taking about carbon compounds and silicon compounds. With that we'll finish this lesson. Okay? Take care, have good food and keep studying. God bless you.